today, that there is a string. Let me draw the case here. There's a string which is in slack state. String which is in just a second. Right now. This is the string. What is this?
So you should perhaps choose number 2.
Yeah, correct. Yeah, first one. There's a string taken which is in slack state, and this length is root 3 by 2 L, where L is length of string. There is a bob over here. We may negate dimension of the bob, mass being m. This is the point of suspension of the other end. You let loose the bob. This bob is to fend for itself. When the string will get this position, that is when it will render its full length L, what will be speed of bob? That's what being asked. What will be V at that instant in time, where it is in its vertical position? So how will you go about this question? Get me some idea.
The ball will pursue a. That's a really nice erasing effect. Anyway, the ball will pursue a straight line as long as the string
Yeah.
becomes taut. And from there we can
Okay.
just apply energy conservation, I suppose.
Okay.
No, I honestly,
So
we don't need to do any of that. We can just apply energy conservation between the initial and final states. It doesn't
can
matter
we
where the ball.
conserve energy from this state to the state termination?
Yeah, potential energy and kinetic energy. Total mechanical energy should be conserved, right?
Can we conserve? That is what the question is positioned at. Can we conserve energy right from the state when it is being let loose till it culminates in the vertical position?
I see what you're getting at. Yeah, okay.
Right.
Yes. The string does do some amount of work when the ball, I suppose, changes its trajectory from vertical to circular.
Correct. So, what is the inference that you are drawing? Certainly, will not be able to conserve right from the state
Yeah, okay, but
to
maybe
where we
what
want
we can do is conserve energy from that moment when the string becomes taut
it.
all the way to the end.
Okay, and let me again rephrasing the question. Ask you: could you please get me what will be amount of work done by string? Because string is the point of contention over here, right?
Yes.
Yeah. So this is I make no bones about I have an axe to grind over here. And that being, I want to emphasize on what we did begin with. We began with the premise impulsive force can do work in no time. I want to actualize it. This is a problem which will make you understand what will be work done by impulsive force given a situation. Not in all the cases we are in a position to calculate, but certainly in this case we can calculate work done by impulsive force. Impulsive force being tension over here. So, what is work done by impulsive force? If that being asked, how will you go about it?
Okay, so I would find the state of the system just before and just after the string does its work. Calculate the difference in energy between them, and that must be the work done by the string.
Okay. So, you will check for the state when the string gets stout state, correct?
Yes.
Okay. That I presume that is to say when it falls by certain distance, and that'll be L by 2. You correct me on that if I'm going
Yes,
wrong.
that would be L by 2, correct.
Okay, L by 2. So till L by 2, it falls vertically without of much of hindrance under gravity. And as it's fallen by L by 2, speed will be 2g L by 2, which is to get me under root of GL, right?
Yeah.
Okay. Thereafter, what will change, Vasudev?
At this
We can
point,
mark
we'd
the
have.
angle as well.
Yeah,
So
we
let's say
can
this
just mark the
angle.
angle, yes.
Yeah, this angle is theta, which is 60 degree or
Yes.
30 degree. What will it be? L by 2 is, this is L by 2, this part is L by 2, right?
That would be 30
And this
degrees.
part is, yeah. So we know theta, alpha, we know the relation. We can break velocity into components over here, one being tangential, the other
Yes.
radial, right?
The radial component would get nullified by the work of tension.
Yeah, the radial component will get nullified, which will help us calculate work done by impulsive tension, right?
Yes.
Because what we can from here gauge is work done by impulsive tension will be equal to change in kinetic energy in that direction, right?
Yes.
There was a component of under root of GL which tension, impulsive tension reduces to zero, right there?
Yes.
We'll be able to calculate, and as you said rightly so, from here up to this point we are in our liberties to conserve mechanical energy, right?
Yeah.
So from here, which velocity is to hold water? This component, correct?
Yep.
This component velocity, this will be nullified. And with this component of velocity, we'll be able to conserve energy from this state to this state, correct?
Yes.
Okay, good enough. This was one question I wanted to deal with. And the other one, which is a mundane question from Ayurveda, I think I'll just ask how will you go about it? It's given to you that there's a ball out here, it being let loose. This height is h for us. This height is h for us. This circular track of radius h by 2. So what will be the maximum height to which the ball will rise? Mass of ball being m. How will you go about this one? What is the maximum height to which ball will rise? There's no friction present anywhere. The track given to you, certain part of it being circular.
Should raise back to its initial height.
Maximum. Yeah. Will reach its initial height. Are you sure?
I don't see anything that might be sucking its energy away.
Think about it. Reevaluate.
It's not tied or anything, is it?
No, it isn't tight.
Hmm.
It's free to move on the surface, slide on the surface.
Well, the surface always applies the force
Yeah.
normal to its velocity, so it can't be doing
Hmm.
any work unless that is the ball kind of rolls off that
Hmm.
ledge and
Agreed.
it takes a parabolic path. In that
No,
case, yes.
no, no. That been ruled out. That been ruled out. I have to protest a point over here, and that the ball cannot reach topmost position. It will not be possible for ball
Oh
to
yeah, yeah,
make.
yeah. Okay, you do have a point. You won't be able to reach the high
Yeah.
again because vertical circular motion won't be able to complete the circle.
Yeah, it'll lose contact.
Yes, it'll lose
It
contact.
will
I
lose
should have seen that.
contact. So we need to figure where will it lose contact. There are, by the way, that will also not be the maximum height. After losing contact, it will move on a parabolic path, correct?
Yeah, so we can calculate its velocity at the bottom, and using that, I think there's a formula for which you can calculate the angle at which
Mhm.
it will lose contact with the surface.
Correct.
Uh,
Correct. At
from
that point,
there,
we
we
can
can just
calculate
consider parabolic
velocity.
motion, consider the highest point in its trajectory.
Exactly. Exactly. So I think you'll be able to see through the end of the question, right?
Yes, yes, yeah.
Okay. The other one which featured in IIT, just to mention, if I haven't taken this one, there was a bob given to you, and there was a hypothetical line at a distance L by 8 from the bob's position, vertical position. This is L for us. Being asked that if the bob is to cross this vertical line, this one, they have taken it a bit too far. L by 8 will be not this far. Nevertheless, if the bob is to cross this line at an angle 90 degree, then what should be the value of u? what u should be provided to the bob at the bottommost position so as to cross this hypothetical line at an angle 90 degree.
The second time it crosses it.
Yeah, the second time it crosses. This featured in IIT.
Okay. So that would,
How did you
if it crosses it at an angle of 90 degrees, that would have to be the highest point in its parabolic path. I mean,
know? No, but
you know for a fact that it loses contact
yeah,
at some point. Yeah, that has to be the
yeah,
case. And
correct.
over that, if it has to be 90 degrees, then it has to be the highest path, the vertex of the parabola.
Hmm.
Uh,
I think you can walk me through, and I'll let on you. So the
just
points to reckon, yes, it'll have to be in a state where it has to make an angle 90 degree, and for that to get actualized, it cannot complete vertical circular motion, right?
yes, that's true.
So somewhere this string is going to get slackened. Thereafter, it'll follow parabolic path, and that ought to be the maximum. As velocity is perpendicular, that ought to be the maximum height, right?
Yes.
So we'll be able to weather it, I presume.